All right, so with us being on an AB schedule, I am teaching all of systems of inequalities today to leave Friday open for questions. So whenever you're doing systems of inequalities, it's just like systems of equations. We're still going to graph our two lines, but today we have to deal with solid lines and dotted lines. And then instead of finding a point of intersection, we're actually looking for a shaded area of intersection. And so we are actually going to graph both of these, and I'm going to give you guys some tools and tricks to help you guys graph these with ease. So I want you to look at this first example. We're going to graph it in red. And we have 1/2 x minus 2. So if you start out at -2 on the y-axis and go up 1 and over 2, it's going to give us our line. And if we go back to indicator 7, you would know that an or equal to means that we are going to have a solid line there. Now, I want to ask you, this symbol here means less than. So should we shade above or below this line? And the answer is we're going to shade below because less than means below. So I'm just going to put a B here. We're going to shade below this line. Now, our second inequality, y is less than or equal to -x minus 1. Our symbol tells us it's going to be a solid line. And we are going to be shading below this one as well because it is also less than. But we start out at +1 and we go down 1 and over 1 and follow that pattern and make our solid line. So whenever you graph two lines, it basically creates 4 sections of points. So 4 sections of the graph. So we got a section over in this area, we have a section up here, we have a section to the right and a section at the bottom. Now, we are supposed to be shading below both lines. And the only area that's below both lines would be this area right here. And I really wish we had a highlighter tool, but we don't. But this area right here is the area that is below both of those. So any point in this shaded area would be a solution. So like this point, 2, -3, that's a solution. The point here, 0, -4, that's a solution. This 3, -4, that's a solution. They're actually a solution for both of the inequalities, not just one. It's a solution for both of them. And then if you actually wanted to know this area over here, this is not a solution. This is not a solution, and this is not a solution for both. So this green area is the only area where you could pick any point in this area and it would work for both inequalities. All right, now moving on to the second one. We have this time y is less than 1/2 x plus 1. So just based on this symbol, we're going to see that it's going to be a dashed line and we're going to shade below. So we're going to start out at +1 and go up 1 and over 2, up 1 and over 2, or down 1 and back 2. And we're going to make that dotted line. And I'm going to put a B for below. We shade everything at the very end. Now here, this tells me it's going to be a solid line, and I'm going to shade above. So here, I start out at -2, and I go up 2 and over 1, up 2 and over 1, up 2 and over 1, solid line, and above. So we want to find an area, and again, we have 4 sections to pick from. We got a big section up here, a little itty-bitty section, and then these 2 bottom sections. So I'm just going to number these just so it's a little bit easier to see. So we have 1, 2, 3, 4 different sections of this graph created when those 2 lines are put on there. And we want to find the section that is below the blue line and above the pink line, and the only one that fits that is section 4. So any point in section 4 would be a solution to both inequalities. So it means you could plug in the x for x and the y coordinate for y, and you would get a true statement for both pieces. Okay, moving on to example 3. Again, we're in slope-intercept form still. So this first inequality, we have x is greater than or equal to -2. So we don't have a y, but we know x is -2, and it's a solid line, and it's a vertical line because it can't touch the y. So we have to ask ourselves, greater than or less than, which direction would be greater than -2? And on this one, it would be going to the right, because greater than, we want to go towards the positive x values. Now for our second inequality, we're going to graph it in blue. All right, our symbol tells us it's a solid line because it's or equal to, and we're going to shade above because it's greater than. So we start out at +2 because that's our y-intercept, and then we can go up 1 and over 2 or down 1 and back 2 and get that solid line in. So just like the last time, we created 4 sections of the graph. There's 4 sections here. And we want to ask ourselves which one is to the right of the pink line and above the blue line. And our answer to that is section 2. So this section up here, any ordered pair in this shaded area would be a solution to both inequalities. Now, the last 3 examples are the exact same concept, except we do have to put those into slope-intercept form first. So let's zoom in on number 4. And make sure you have plenty of space to work, but you can also see the graph. All right, so our first inequality, we have 2x minus y is greater than 3. Now, if we subtract our 2x over, we get -1y is greater than -2x, and our 3 is positive, so we bring that down as a +3. Now, we have to divide by -1, which requires us to flip this inequality and then divide. 2 negatives become a +2, and then it becomes a -3. So when we graph this, this is what we're going to graph. So we can see it's going to be a dashed line, and we're going to shade below because our solving required us to flip it. So we're going to start out at -3, go up 2 and over 1, and make our dashed or dotted line, however you want to say that. And sorry, my lines are not straight on this screen. All right, then our second inequality, 3x plus y is greater than 2. All we have to do here is subtract our 3x, and we get y is greater than -3x plus 2. Our y is by itself, so we are good to go. And on this one, we're also going to have a dotted line, but it's greater than, so we're going to shade above. And I probably should have put a B for below on that one. All right, so we're going to start out at +2, and we're going to go down 3 and over 1, down 3, over 1, and get that, or up 3 and back 1. We're going to get that nice dotted line as much as we can. All right, so we have created, and we're going above this line. So we have 3 sections of the graph. We're only shading one. Which one is below the blue and above the pink? Below the blue and above the pink would be section 3. And now, when you guys are working, you do not have to number your sections. This is just a little bit different since you guys all can't see me like point to the graphs on the videos. I'm just numbering those for you to see. If you guys just want to go ahead and shade your solution, you do not have to number those. It's just an easier way for me to communicate with you guys through the graph. All right, so I have 2 more of these. Same thing, we got to get them into slope-intercept form first. So let's look at our top inequality for number 5. We got 2x minus 3y is greater than 9. I'm going to subtract my 2x over. So I get -3y is greater than -2x plus 9. Dividing by -3. Dividing by a negative number makes me flip it. So we got +2/3 x minus 3. So here we are going to have a dashed or dotted line, and we're shading below. All right, -3, +2/3 slope, up 2 over 3. down 2, back 3. We don't have room to make any more, but let's make our nice dotted line. Hey, that one wasn't a bad line. Maybe I'm getting better at this. All right, now for our second inequality, let's get a different color going. So we got 2x plus 3y is greater than or equal to 3. Subtract our 2x over. So we got negative 2x, and our 3 is positive, so bring that down. This time we're dividing by a positive, so we don't have to flip it. But we got negative 2/3 x plus 1. Now make sure you're paying attention to details. I did not bring down that or equal to. So we know it's going to be solid, and we're going to shade above. So we know it's a solid line and shading above. So we're going to start out at positive 1. Our slope is negative 2/3, so we're going to go down 2 and to the right 3, or we could go up 2 and back 3. And we're going to make a nice solid line between those points. All right, so we have 4 sections. Section 3 is super small. So we want to find one that goes below the green, or below the blue, but stays above the pink. And the only one that does that is that itty bitty section of section 3. So you can have a small solution set, and that's okay. What you can't see is as those graphs tend to extend out, the area that's not part of the graph, it will get bigger over time. But just from what we see, it's that little small section. All right, now our last example is another one in standard form. So we subtract our x over, and we get 3y is less than or equal to negative 1x plus 6. Divide by 3. And we get y. We divide it by a positive, so we keep it the same, negative 1/3 x plus 2. So it's going to be a solid. We're going to shade below. We're going to start out at positive 2, go down 1 to the right 3, or up and back 3. Got a nice solid line, and I'm going to put a B for below this line. Now our second equation, 2x plus y, is less than negative 3. Subtract my 2x. And it's a y by itself, so we are good to graph this time. It's going to be dashed, and we're shading below. So we start out at negative 3, and we go down 1 and to the right 2. We're running out of room, so let's go up 1 and back 2. And let's make our nice dotted line. And we know we're going above this line. So we want to be above the blue and below the pink. And we have 1, 2, 3, 4 sections to pick from. And the section that is below the pink but above the blue would be section 2. So we're staying above the blue, below the pink. And if you have questions just on basic inequalities, don't forget you can always go back to our first 9 weeks and look at indicator 7 if you want to see in more detail graphing inequalities with solid lines, dashed lines, things like that. And my Google Meet will be open today and tomorrow. So if you have questions, just look for the times and log in and ask questions. And I will hope to hear from you and see you all soon.